In this demonstration, we are going to show application portability across on-prem and cloud Kubernetes clusters leveraging Cloud Block Store and Pure Service Orchestrator. This enables developers to use existing application deployment configurations without having to worry about where the applications are deployed and where the persistent storage is located, whether it be on-prem or in the cloud. Historically, the storage class for application storage would need to be modified in the developer's scripts depending on where they were deploying their application, taking time and requiring the developer to know exactly where they were deploying and the available persistent storage. With Pure Service Orchestrator and Cloud Block Store, this is now in the past. The same storage classes exist in your cloud and your on-prem Kubernetes clusters. Here we see a simple script to create persistent storage using storage class Pure Block, and then deploying a Microsoft SQL Server for Linux in a container using that persistent storage. We have already created the secret defined here for the database password. I'm now going to copy that particular script to a physical server in an on-prem Kubernetes cluster and to a cloud instance in AWS, also part of a Kubernetes cluster. So that copy is now completed. We'll go and look at the two nodes that I've just copied it to. We have here, firstly, the on-prem solution, which is a UCS blade running CentOS 07. And then over here, I have the AWS instance running Ubuntu 16.04. On both nodes, I'm going to use the exact same kubectl command to deploy the SQL deployment. We're not modifying anything at all. Do that. And both have now created a persistent volume and a deployment. So we'll have a look at what that looks like in the environment. Here, actually, you can see the EC2 management console where I have my 3-node cloud AWS instances. And this actually is the Cloud Block Store that's running in AWS. So firstly, we'll go to the cloud AWS cloud Kubernetes cluster, and we'll see that a new deployment has been created called Microsoft SQL deployment, and we'll just drill down through that. Firstly, we see a replica set, and then we'll also see that we have a pod that's been created. That pod has got a persistent volume claim, which is from the storage class Pure Block, as we saw in the script. And if we go to the on-prem Kubernetes cluster and have a look at the deployments that have been created there, we'll see that we have exactly the same deployment, Microsoft SQL deployment, and we'll drill down through that. And we can see here, there's again a replica set, which is creating a pod. And that pod, again, a new persistent volume claim, again, using the same storage class, Pure Block. And this has been created on a physical flash array where the cloud Kubernetes was deployed on a Cloud Block Store. Just out of interest, I've also created a service on both the Amazon cloud instances of Kubernetes and the on-prem that allows the Microsoft SQL port 1433 to be exposed to the outside world, in this case port 32290 in the cloud instance, and in the on-prem solution, again 1433, in this case going to 32521. What we're going to do now is we're going to go on to Microsoft SQL Server Management Studio. And firstly, we're going to just prove that the databases did come up and we can connect to them. So here, this is the on-prem solution using that 32521 port, and we're going to connect to that. Now we'll go away, connect to a brand new SQL database that's just been created. And then we're also going to connect to the cloud instance, again, using that 32290 port that we created through the service. That's going to connect. And now we have another Microsoft SQL database. Both SQL databases created in exactly the same way using exactly the same script with no modification, one on-prem and one in an AWS Kubernetes cluster. Thank you very much.